Alright, ladies and gentlemen, this is some notes on points, lines, and planes, 1, 1, and 1, 2. The 1, 2 is the linear measure. So, your goal, your objective, you'll be able to identify and label points, lines, rays, and planes, and apply linear measure to determine unknown values. So one of the things you need to know, that math is not just about number crunching. It also involves creating a mathematical model to represent what's going on in our world. So we have a world, a world is circular. So to represent the shape of the world, we know it's a circle. And of course there's a lot going on in our world, like houses and cars and mailboxes and all tons and tons of things going on in our world. Math is a part of it. Our goal as mathematicians is always to create mathematical models of what's going on in the world, to identify what has happened in the past, to determine what might be happening in the present, and help predict what's going to go on in the future. So today we're going to learn about how to create a label, a point, a line, and a plane correctly when we're developing these mathematical models. So we see that this is one piece of the roof. To say that this edge of the roof, the exact edge, because there's 4 edges of this roof that we can see right here in our model. If I want to refer to this particular edge right here, we label it AB. So this would be ledge AB. Alright, so let's dive a little bit more into this. Some vocab. A point is a location. It has no size, length, width, or depth. So we have point A. So it's just a little click of the button, that little spot. It's called A. Another example would be B. So you can label it with any letters or any type of symbols to also represent these points. A line, it contains points and continues infinitely in 2 directions. So keyword with a line, it goes infinitely in 2 directions. So a line doesn't stop on both ends. It actually continues to go on and on and on. So there's an arrow on the left hand side and an arrow on the right. Alright, looking at this, the word collinear. Collinear is 2 or more points that fall on the same line. So we see here in this picture we have A, B, and C. All 3 of these points fall on the same exact line. You could draw a line going through all 3 of the points. That's what collinear means. A ray. Ray is a line segment with one endpoint where it stops on one side and on the other side just keeps going on and on and on. That's why it has an arrow on it. This is called an arrow. Oh, sorry, it's called a ray. It has an arrow on there. So AC is a ray. A line segment. A line segment is a piece of a line that has defined endpoints on both ends. So it would be A and C. So A is the endpoint on one side of the line and C is the endpoint of the other side of the line segment. So a line segment has 2 endpoints on both sides. Some more vocab. A plane extends infinitely in 2 dimensions. It has no thickness. How to label a plane? It has to have 3 letters to identify the plane. Or a plane could also be identified with 1 letter that is italicized, meaning it has that little diagonal shape to it as you've seen in Word, in a Word document. So a plane is 2D, it's 2 dimensions. So you heard of 2D and 3D before with TV and video games and other various media outlets. You've seen 2 dimensions versus 3 dimensions. You know the difference between the 2. Coplanar. Coplanar is when points that are on the same plane are coplanar, meaning if you have 2 or more points that are on the same plane, those points are called coplanar. For example, if we have multiple people on the same floor of a building, so Johnny, Susie, and Allie are on the first floor of a building, Those three people are coplanar, meaning that they're on the same first floor. So that's coplanar. So as we were saying before, of different planes, here's a picture to help describe. When we're talking about with floors, first floor, second floor, third floor, fourth floor, these are considered to be 4 different planes. So if everybody was on the first floor, that means all of them are coplanar. They're all on the first floor. A different plane would be the second floor. So it's above it. Notice how these two planes, they're not crossing each other. They could cross each other when we get a little bit more fancier in the notes. But in this example, in this building, the planes are different. It's the first floor and the second floor. They're separated from one another. So the second floor is another plane. A third floor could be a different plane. A fourth floor could be a different plane. That's some examples of different planes. Cakes, different layers of a cake, are different planes of a cake. So layers would be another way to think about planes. Here's a picture of a 2D plane, an old school video game, a little Super Mario. And then, as the years gone by and the video games got more advanced, it became 3Ds. Now here's Super Mario again, but now in a 3D world, where it has some depth. Alright, another way you could look at it, if we got a green box here, or a box from the front of the room like in class, the top of the box, A, C, F, E, that green part is considered the top of the box. The pink part is the bottom of the box, B, D, G, H, that plane down there, the bottom of the box. Just to help give you some visual aid. Now, ask yourself, can you identify / name the 2 highlighted planes of blue below? Remember, they need 3 letters or an italicized letter. Notice here there's no italicized, so in other words, we need to identify the top plane with 3 letters and then the bottom plane with 3 letters. First, try it on your own. You could hit the pause button. Alright, now the top plane, we could label this top plane as ACF, or we could label the top plane as ACE, or the top plane as EFC. Any combination of the 3 letters on top will identify the plane on top. To identify the plane on the bottom, BDG is one example, HGD is another example, HBD is another example of the plane on the bottom. Now in this picture, I highlighted 2 planes. I highlighted the top plane, the top of the box, AEF, and then the front of the box here in red, ABD, is considered the front of the box. Now I want to know, are these 2 planes parallel? Well, if we look at the problem beforehand, these 2 planes, they don't cross each other. And you know 2 lines, parallel lines, don't cross each other from Algebra 1. So that also applies to planes. When 2 planes don't cross each other, these planes are considered parallel, as you see here. These 2 planes, however, the red one and the blue one, they do cross each other right here at A. I believe that's C there, so AC, that whole line segment, the red and the blue are crossing each other. So these 2 planes, the top of the box and the side of the box, they are not parallel planes because they're crossing each other. Name 2 colors that are perpendicular planes. Well, perpendicular planes are planes that do cross each other at a 90-degree angle. So if this is a perfect rectangular box, 3D box that is, the red plane and the blue plane, they cross each other at a 90-degree angle. So the red plane and the blue plane, they're perpendicular planes. Now the yellow and the blue, they're also perpendicular planes, because it's like the top of the box and the back of the box. That creates a 90-degree angle up here. So they're also perpendicular planes. However, the red and the yellow, they don't cross each other, and they seem to be parallel because they're both, the red plane and the yellow plane, are perpendicular to the blue plane. So the red plane and the yellow plane, those two planes are considered parallel. All right, looking at this problem here. Can you identify 3 points, 2 line segments, and 2 planes? Why don't you hit the pause button and determine, see if you could do that. Okay, let's go over some examples here. 3 points in this box. Well, point A, point B, point H, points G, D, F. Any one of the letters are considered points. All you had to identify was 3 of them. 2 line segments. Well, AB, line segment AB, is considered a line segment because line segments consist of 2 letters. And when you do those line segments, remember you have to make that line above it. So if you have line segment AB, it has to be AB, and then you draw that little line segment above it. Another example of a line segment will be FJ. Those 2 coordinates make a line. So you got FJ, and you do a little line segment above it. Now 2 planes. Planes considered are 3 or more letters. So you have to use at least 3 letters to make the plane. So if I want to make the top of the box, that would be A, B, H. I would do plane A, B, H. Another combination of a plane will be the bottom of the box, F, D, J. That could be another plane. And then the right side of the box, B, C, E. That's another plane, B, C, E. So those are some examples of planes. All right. So looking at this, line not contained by a plane. So looking at the picture on the left here, we have a green plane with a black line going through it. And it black line intersects the green plane at point R. That's where it crosses. So you can tell that by little dash lines there. Line X and point R are in plane N. See, it's the italicized N. So the green plane is green plane N. So point R and point X there, because it's a little hidden green line there. Both of these 2 points are in plane N. Point R lies in plane N. Plane N contains R and X. Line Y intersects plane N at point R. Point R is the intersection of Y and plane N. Lines Y and X do not intersect. Even though it kind of looks like it in our 2D picture. Turns out, since this green line is not going through point R, this green line is kind of like in the background. It's behind this black line Y in the plane, in the green plane. As you can see, we have 2 planes here on the right hand side, a yellow plane and a green plane. You can see that they're crossing each other. They cross during this black line here, black line AB. Those 2 planes crossing, and they make a line segment when 2 planes cross. And you see these notes here. Here's some more practice. Here's a real life picture here where you could practice some of these line segments and see parallel line segments and different points. See if you can identify on the Eiffel Tower. Some more practice. Some more practice. Now let's see if we could draw them. So we're going to draw. So line segment AB is on plane Q. So I got myself a nice little plane. Plane Q. That's got to be italicized. Can't really do that too well. So we got line, put 2 dots, A, B. So that's line AB on plane Q. ST intersects AB at point P. So you could draw another line here. And say the intersection right there is P. And we can label it ST. So this is just drawing everything. So you gotta be asked to draw some of these things too. Then you gotta remember what collinear means and not collinear, and putting it all together. You could try finishing this off on your own. Alright. To help you remember what a ray is, it's like a ray of sunshine. Starts from the center of the sun and shoots out. So a ray has a starting point and then keeps going on and on and on forever in the other direction. We also need to identify lines, line segments, and rays. So right here, since this does not have any arrows, this is considered a line segment. Since it has 2 arrows on it, it's considered a line. This one has a start point, and on the other side of the segment here is an arrow. So this is considered a ray. This one's considered a ray. This is a line. Line segment. Line segment. This is considered a line because it has those 2 arrows on the end of it. This is a ray. I think you get the idea. You see that's a ray, that's a line segment. Now we're going to get a little bit more fancy. What is the dashed green part of the figure below? So it's still the same concept that we've been doing, except now it's kind of hidden with some other lines and line segments. Our goal is to focus on just the green guy here. So this dashed green line segment, well, it has 2 endpoints. Since it has 2 endpoints, you know it's a line segment. So the answer would be C, a line segment. On to the next here. In the directions up here on the top left-hand corner, it says, which of the following figures shows a dashed green ray? So we're looking for a green ray. So looking at figure A, we have a green line, dashed line. It has 2 arrows on it, so that's not a ray. This has 2 endpoints in B, so that's not a ray. In figure C, we have 1 endpoint and an arrow on one side of that line segment. That's considered the ray. So all of this really just comes down to what is a ray. So it'd be option C. Alright, ladies and gents, we made it through the end of this lesson. Once again, that was points, lines, and planes. And we're going to do a separate video for the linear measure. So this was 1-1, points, lines, and planes. Hopefully you were able to identify and label points, lines, and planes. And apply a little bit of linear measure to it. And we're going to talk more about linear measure. If you have any questions, please email me or come to Extra Help. I'll be happy to help you out. Alright, have yourself a good day. Bye-bye.